Let's discuss some of the elements from the systems engineering process chart in detail. Let us first take a look at the role of master data in warehouse planning. In any warehouse planning project, one of the most fundamental inputs is the item master. This dataset provides a comprehensive, qualitative and quantitative description of all stock keeping units, SKUs, as registered in the warehouse management system. In combination with the transaction data that we'll discuss in a bit, it forms the basis for understanding how products flow through the warehouse and how storage and picking systems should be designed. The item master includes basic but essential information. This typically begins with an item number and item name to identify each product uniquely. Beyond that, the dataset contains physical attributes such as weight, length, width, and height. These parameters are vital when calculating storage requirements, planning racking systems, or configuring automation solutions. Equally important is the sales or handling unit. This defines whether a product is typically stored or picked as a single piece, a full carton, or a larger case. All of this information is considered required and should be present for every item listed. In practice, there are also several optional data fields that can become mandatory depending on the planning scope. For example, the number of pieces in a carton, the number of cartons per pallet layer, and the number of layers per pallet are critical when dealing with pallet storage or planning vertical space utilization. Product category information, such as whether an item is considered dry goods, cosmetics, or fresh produce, helps define storage zones and may influence safety or consolidation rules. The temperature zone, such as ambient, chilled, or frozen, is another decisive factor, particularly in facilities where climate control impacts layout, infrastructure, and material flows. It's important to note that the item master often includes far more SKUs than what we observe in the sales data. In fact, it is common to find a large number of discontinued or slow-moving items still registered in the system. This mismatch can lead to misinterpretation of the data. As such, it's often necessary to work with the client to clarify which products are still relevant for the planning process. Understanding which SKUs are active, which are frequently picked, and which are essentially obsolete helps avoid misleading results, especially when simulations or capacity calculations are involved. The table at the bottom of the slide shows 3 illustrative SKUs. The first is a 500-gram pack of fusilli pasta, which is picked in cases containing 4 units and stored in ambient conditions. The second item, a roll-on deodorant, is also stored ambient but is picked in cases of 6 units. The third item is a 1-liter carton of milk. Unlike the others, it is picked by the piece and stored in a chilled zone. What these examples highlight is the high variability across items in terms of physical size, weight, handling unit, and storage requirements. This diversity is typical of most item masters, and it makes clear why data completeness and consistency are so critical. Errors, gaps, or outdated entries in the master data can severely compromise the quality of warehouse designs and simulations. For that reason, a thorough review and validation of the master data should be considered a mandatory step in any warehouse planning or automation project. Let's have a look at the exercise files that I have uploaded to the e-learning platform. You have 2 master item files, one for case picking and one for an e-com warehouse. Both files have been provided by the friendly people of SSI Schaefer for this course. So let's have a look. By the way, if you're wondering how you can import the files to this Jupyter Notebook, there is YouTube, there is LinkedIn Learning, there is ChatGPT. You figure this out yourself. All right, so let's have a look. Let's first look at the master data file for the case picking system. So by the way, I'm using Jupyter Notebook here in case you have not come across it. It's a very useful tool. So I recommend you use the same thing. Okay, so let's look at this. Here we can see we have a bunch of columns included in the item master. For instance, we have the item ID, which is the unique SKU number. There are some names that look funny. We should talk about those later. We have one column that is called zone, which refers to the temperature zone in the warehouse. So for instance, you can see there's dry, which means this is ambient temperature, which is like 15 to 20 degrees centigrade. We have some none values, which means, well, there was no value included. And we probably have some more. We will check this in detail later. We have dimensions of the product, which are depth, width, and height. But we also have C depth, C width, and C height. Now, what does that mean? Probably this means that we have the dimensions of the individual piece. So that's the consumption unit, so to speak. And we have the dimensions of the case. So that's the wholesale package. For instance, think of a can of beans. You would purchase a can of beans in the supermarket, but that can of beans comes to the supermarket in a cardboard tray, which is referred to as a case. And so the logistical unit in the warehouse that supplies the supermarket is the case. And if we want to do anything with that logistical unit, with that flow unit, we have to understand the dimension of the case. The dimensions of the piece don't really matter for logistics in that case picking warehouse. Importantly, we also have a column that provides the unit of measurement dimensions. So here you can see the first product, 180 in depth, 170 in width, 1 in height. Now, this is provided in centimeters. Next one, 165 in depth, 55 in width, and 0 in height. That doesn't make sense. That's provided in millimeters. For the cases, we also have the unit of measurement dimensions here, centimeters for the first product, centimeters for the second product. You can also see already that a lot of dimensions for the cases are missing, which will provide a challenge for us later on. We also have weight, both for the individual pieces and for the cases. And we have information about the number of pieces per case. So how many cans of beans do we have in one cardboard tray? All right. So this is a very typical master data file for a case picking system. Let's have a look at the second one, the ecom file. Okay, so this looks very similar. We've got an item ID, we've got depth, width, height. By the way, if you're looking at a product, it's not obvious what is depth, what is width, and what is height, because you can hold or turn the product in different directions. So the height and the width and the depth, these are descriptive names, which sometimes are obvious, they make sense, but sometimes you don't really know which one is which. And so this becomes a problem when you do, for instance, volume analysis of products. We also have a temperature zone here. Here it's called temperature. You can see some products are chilled, some are ambient. And we have a total of 26,000 rows in this data file, so perhaps some are frozen as well. We've got a pick type, so we've got some piece picking products, some pallet picking products, but also some full case picking products. We do not have units of measurement dimensions here. So we don't know if these are millimeters or inches or centimeters, but we can make assumptions, of course. Probably this will be millimeters, and probably the weight will be provided in gram. So please have a look at those exercise files, play around a little, and you can already begin to look for problems in these files, because these files are not free of flaws. In the next video lecture, we will talk about the process of importing the files and some of the pitfalls that come with importing the files. And you can try to find out if these files that you find on the e-learning platform have some problems that you can already identify.